Welcome to the lesson, Why Do Scientists Compare Results? We're going to investigate accuracy in measurements, the uses of similar and different tools, and discuss why scientists compare their results to those of other scientists. Have you heard the carpentry saying, measure twice and cut once? You really only have one chance to cut a piece of wood to the correct length. Carpenters don't want to waste wood, and careful measurement is important in many areas. Taking the time to take accurate measurements usually prevents a lot of headaches later. Let's look closer at measurements. When people move to a new house, sometimes furniture won't fit in the new space, or cars won't fit in the garage. You can measure in advance of the move or change. Click the buttons to find out about a change at your school. What if your school decided to put in new, smaller lockers? You will need a new backpack to fit in the new lockers. You found one that you really like, but you need to measure it to be sure it will fit, and will be as light as possible so it's easy to carry. You also want to be sure it will fit when loaded with books. The locker is 30 centimeters deep, 30 centimeters wide, and 90 centimeters tall. Observing is using your senses to gain information. Let's conduct an investigation to find out the backpack's height, length, and width to see if it will fit in the new locker. Measurement is the process used in finding out a quantity in terms of length, mass, or other measures. An investigation is an inquiry following a process to find out about something. Both observation and investigation use measurements as a tool. Let's learn a bit more about measurement. Click the image to learn more about measurement. Not everyone has the same size hands, arms, or feet. So, if we use them to measure, the units would be different. How can we all mean the same thing when we say something is a certain length? When systems are standardized, everyone agrees what the units will be. Rulers, balances, and scales are some standardized tools for measurement. The measure will always be the same. A ruler measures length. Length is how long something is from one end of it to the other end. Millimeters measure the length of very small objects, like the thickness of a paperclip. Centimeters measure slightly longer objects, like a shirt button or the width of your fingernail. Meters measure the height of a person. An Olympic pool is 50 meters long. Kilometers measure longer distances, like the distance from one city to another. Mass is how much matter is in an object. A balance is used to measure mass. Milligrams are used to measure the mass of very small, light objects, like a leaf. Grams are used to measure slightly larger objects, like an apple. Kilograms are used to measure large objects, like you or me. Kilograms or tons are used to measure really large objects, like an elephant. Weight measures the force of gravity on an object. Weight is measured in newtons using a spring scale. Weight and mass are different. On the moon, an object weighs less than on Earth because the force of gravity is different, but the mass would be the same. Now you can measure the backpack with different tools. Here's what you'll use: a backpack, a ruler, a balance, a spring scale, data tables. Here's where you will record the length, width, and height measurements of the backpack and the mass measurement of the backpack. To make a prediction, estimate the backpack's measurements. The new locker is 30 centimeters wide, 30 centimeters deep or long, and 90 centimeters in height. Do you think the backpack will fit in your new locker? Make your prediction in the box, then click OK. To check your prediction, you're going to take some measurements. First, state your goal. Then describe your plan to find out whether the backpack will fit in your new locker. Then click OK. Now you will carry out your plan to check your predictions about the measurements of the backpack. Drag the ruler to the backpack to measure its length, width, and height. Record your measurements in the table. Now you will carry out your plan to check your predictions about the measurements of the backpack. Drag the ruler to the backpack to measure its length, width, and height. Record your measurements in the table. Repeat the measurements 2 more times and record your results. Now you can measure the mass and weight of the backpack. Put the backpack on the balance to take its mass. Record the backpack mass in the table. Click Reset and repeat this measurement 2 more times. Click here to measure the weight of the bag. Enter your measurements here. Click Reset and repeat this measurement 2 more times. Compare the different length and width measurements you made with the ruler. Compare the different mass and weight measurements taken with the balance and the spring scale. Why might repeating measurements be important? How can repeating measurements with the same tool check for human error? Look at the tables and write in the open text box what you think about the results. Finally, did your new backpack fit in your new locker? Remember that your new locker is 30 centimeters by 30 centimeters by 90 centimeters. Write your analysis in the open text box, then repeating measurements helps ensure more reliable data. Measurements taken with different tools may give different measures. Different tools are accurate for different kinds of measurements. Human error can produce different measures. Accuracy in measurement is important. Record your conclusion. Also, state if your prediction was correct, and explain why or why not. Type your answer in the box, then click OK. Remember this backpack? Now try using a non-standardized form of measurement. Use your thumb width to measure the length and width of the backpack. Think of another unit of measurement you could use to measure the on-screen backpack, such as a paperclip or the width of a pencil. Record it in your table. If one of your classmates did the same measurement, what do you think they'd find? That's right. Their measurements would probably be different. Record your results in the table. Use your thumb to measure. Look at the list of items. Let's look at using the standardized measures we talked about earlier in the lesson. When you measure things with these standard measures, will your measurement be reliable? Yes. Can you match the appropriate measurement unit for each item? Drag each item into the correct locations in the table. That's right. We measure lighter things in milligrams, then grams, then you and me in kilograms, and heavy machinery in tons. You've learned a lot about how scientists compare results. Before we finish, let's take a quick look at the main points you covered. Observation and investigation both use measurement as a tool. Using standardized measures may increase accuracy and reliability of data. Measurements taken with different tools or by different people may not produce the same results. It is important to repeat measurements in order to have reliable data. Now that you've finished the lesson, click the Lab Report button to save or print it.